In this video, I do another PDE solution where we get a symbolic result, then we extract the result and we can use it to make an animation. Let's get started. This is the classic square drum problem that is solved through the wave equation. We're going to perturb this square drum diaphragm and watch it evolve as time goes by. We give it some boundary conditions that everywhere along the edge it is not being perturbed. That's showing here. We also give it an initial condition where there's the perturbation written this way, and in addition we're going to let it start from rest. Using our palettes, we have written out the PDE. The next step is to put in our boundary conditions. These are our boundary condition equations, exactly as we normally write them out, but the initial value equations are slightly different. The first one is just fine as we expected, but the second one, you still have to use some maple type coding to get in the fact that if we look at the derivative of z for the third term and evaluate it at t equals 0, that is equals 0, this is how you write it out. Next, we enter what is our perturbation function that is perturbing the whole system. And to make sure that it does look like the perturbation that we are proposing, here's a plot. The next step is to actually solve the PDE given all the initial condition equations and the boundary equations. You can help Maple out solving it simply by telling it that the constants are greater than 0. It still will take some time, and the output will still look quite ugly. Consequently, let's simplify our solution, again telling it that L, C, and alpha, all the constants, are greater than 0. When you do, you get still a huge mess because this is a double summation of infinite number of terms. If you're happy with this solution, you are done. But if you'd like to use the solution to make a plot, then we recognize that we cannot plot an infinite number of terms. We have to give it a limited number of terms to plot. This is the procedure that will do this process. It takes in n, which is the number of terms that you would like to use in creating z. Obviously, we're not going to go to infinity. Because this is a double summation, the way to extract out the full term consists of essentially three processes. One, you want to take the right-hand side of our solutions, which are here. Then you want to combine that so that everything is within the double summation. When you ask for the first operand, it will actually give you the inside summation, and then you have to ask for the operand of that inside summation, and that will give you the expression for the term in z. Finally, to return an actual product to a limited number of terms, we need to do a double add. We need to add twice, and in this adding, we are evaluating a situation where n is our counter, n1, and n1 is our counter, n1 underscore 1. You're ready to plot? Make sure that all your constants are defined with the exception of x, y, and t, and make your life a little bit easier by having Maple return the expression where everything has been evaluated as a floating point. I'm going to use 10 terms. Now we are going to animate this 3D plot of our expression. Again, making sure that x goes from 0 to L, y goes from 0 to L, and L has been properly defined. This is a surface plot. We'll choose an interesting color scheme, give it a title and everything. And again, we're going to plot from 0 to some amount of time. This will have 100 frames. When we click on it, which we can drag it around, we push play, and away it goes. Looking for other examples? Leave a comment down below.